in section 5 for solving right triangles, we're looking at angles of elevation and angles of depression. This is where you're doing application problems. So angles of elevation and depression are both acute angles. They're based on kind of off a right triangle. Angles of elevation go from a horizontal, oops, that's a bad horizontal, from a horizontal, so that's supposed to be a horizontal, up, so it's kind of like a positive angle. You can think of, even though acute angle is always just less than 90, it's not negative or anything like that. So angles of depression, angles of elevation are always acute angles, and they're positive. Angles of elevation though open up, angles of depression open down. So depression, sad face, and elevation goes up, happy face. Oops. And this one's elevation. So usually you have these in word problems, and sometimes it'll say angle of elevation from, sometimes it won't say from a horizontal, sometimes it's from like line of sight. So right, if you're looking line of sight, just means it's a straight horizontal. So because this could be an angle of elevation, or it could be looking down, so it would be an angle of depression at certain angles. So elevation and depression both are from a horizontal. Usually it comes up in line of sight, usually maybe off the horizon or something like that, so it's always off a horizontal. Elevation opens up and depression opens down. So when you're solving these type of applied problems with trig, first you want to draw it out. You're usually going to draw a right triangle, and then label the information that's given to you, usually an angle of depression or elevation, one of the two, and then it might give you the distance of something. So you're labeling one of your sides usually. That's usually how it is. And then you want to go ahead and figure out what you're trying to find. Are you trying to find the hypotenuse? Are you trying to find one of the other sides? Are you trying to find an angle? And label that variable. Then you can go ahead and write your equation that is relating what you're given, right? Either angle and side, or maybe two sides, and then write the equation involving those two and the thing that you're trying to find, the variable or the side or the angle that you're trying to find, and then you go ahead and solve that trig equation. They're usually going to be trig equations. They all are going to be trig equations. And then go ahead and check to make sure that makes sense, right? So if you're finding something that has, say, some popular ones are like you have either a tree or a wall, and you have a ladder or something like that, or somebody's standing here and their line of sight, so line of sight would be this way, and their angle of elevation is at the top of the tree, and this angle of elevation, say, is 28 degrees, and they're standing say 50 feet away, and they're like, from their line of sight down to the ground is 5 feet, and you're asked to find the height of the tree or the height of the wall or something like that, right? So first you would use your, see, I have a triangle here, so I would use my trig formula that gives adjacent, and I'm trying to find the opposite. So I'd find this x, assign my variables, solve for that, but then I need to add this distance, which is 5 feet, right? So I'd do that. I would solve it, and then say if I got like 2,280 as my answer, and this was 50 feet away, that probably doesn't make sense, right? So somewhere I probably went wrong. So make sure you check it, make sure it makes sense. Okay, so let's go ahead and practice a couple. Okay, so here we go. A woman stands 123 feet away from the base of something. So here, say we have the base, and we're standing, this lady is standing 123 feet away, and then from a flagpole. So this base of a flagpole is coming up. The angle of elevation to the top of the flagpole, so elevation off the horizontal coming up, is 26 degrees and 40 minutes. So that means we need to change minutes to degrees. And then her eyesight, so that means from her eyesight. So this is actually from her eyesight. So our flagpole is actually a little bit taller because from her eyes, that horizontal down is 5.30. So that would mean, what, 3 significant figures? So we're going to add this. So once I find this distance from the top of the flagpole to her eyesight, horizontal eyesight here, I'm going to find that as x, and then I'm going to add this 5.3 to that. So first of all, let's change this 40 minutes to degrees. So if we divide that by 60, we get 2/3, so 0.67. So this is actually 26.67 degrees. You know, we rounded it there. Those 2/3 is 0.66 repeated, so 0.67. Okay, now I can take that and what I want to do here, actually I probably can find x first. There's no way that you can write this and add it into it, but we'll just add 5.3 at the end. So if I guess I go 26.7 degrees, right? Because proper sig figs would be 3, correct? Because there's a 0 here. Alright, so we'll use the proper one. So, okay. So anyways. Okay, so now I look at what I'm given. This angle. And this side. And what I'm trying to find, x. And write my equation, right? So what is this side relationship to the angle, and what is the 123 in relationship to that angle? So we have adjacent and opposite. Usually most times you are going to use tangent. So this tangent of the angle we're given, 26.7, and that equals opposite over adjacent. Now we can go ahead and solve this, multiply both sides by 123. So I'm going to take 123 times tan 26.7, and that's going to give me x. That is not the height of the flagpole. Remember, we have to add that. We have to add this 5.3 on after we do that. So let's go ahead and figure that out, and then we'll add the 5.3. Okay, so if we go ahead and round proper to sig figs or whatever, you get 61.9. So that's not the height of the flagpole. Now we have to add that 5.30 onto that. So we get 67.2. So there is the height of the flagpole, and that's feet, right? And that kind of makes sense. I'm 123 feet away. Kind of makes sense. You know, it's not outrageous, right? So, and remember, what if it makes sense should be, remember this hypotenuse should be the longest side. Okay, so that might help you if you're ever given the hypotenuse that your other sides can't be bigger than that. So that's a way to figure out if it makes sense if you're given the hypotenuse or if you're trying to find the hypotenuse. So that's the height of the flagpole, 67.2 feet. Okay. Okay, so here's another one. We're at a cliff. So here's a cliff. Draw your cliff. David, you're at the top of the cliff, so we're up here, and he observes a lighthouse at 430 feet offshore. Okay, so we go from the shore, and we go 430 feet from the shore, and there's a lighthouse. Let's fix this. Oh, jeez. So there's the lighthouse down here, and so there's the lighthouse coming up. And then we want to find the angle of depression from the top of the cliff. So from the top of the cliff, here's the horizontal. So if you want to do that dotted line, we want to find this angle that's going down. I think it's actually going to the base of the lighthouse, so let's go ahead and correct that. So remember, angle of depression goes down, but it always goes from a horizontal, so we have to draw the horizontal. So we're actually not looking at this angle. Don't want that one. We actually want this angle right here's the angle that we want. Well, if you think about it a little bit, you can draw this lighthouse all the way up to connect to that. So don't we really have a square right here? So that means this angle right here would be the same as this one, right? Because this line would be parallel to this one down here. So it's this would be a transversal, this hypotenuse would be transversal, right? So those angles are the same. Or, right, this is 90 degrees. These are all right triangle application problems, so your one of your angles is going to be 90 degrees. So this angle right here is just 90 minus this green one, right? The angle of depression. And this angle right here in green down here, well, wouldn't that also just be 90 minus this one right here, which is the same as the green one? So we're looking for this angle down here. Let's keep with green, I guess. All right, which is the same as this angle of depression. All right, so we're 430 feet away, and we want to find this angle down here, angle of depression, and the cliff is 210, right? So now I have two sides, and I'm trying to find the angle. So the angle of depression, which is the same as this corner one, bottom corner. Well, if I want to try to find that, so we can label it X. Well, what is this side, the cliff, in relationship to that angle of depression? Or that's not the angle of depression, but it's the same as that angle up there. That is opposite. And what is the 430? That is adjacent, which again is tangent. So tan of our angle that we're trying to find, right, is equal to the opposite, the cliff height, divided by the adjacent, which is our offshore distance, which is 430. So when we're finding the angle, we want to do inverse, right? So I do tan inverse of my ratio here, opposite over adjacent, and that's going to give me my angle that I'm after, which is the same as this angle of depression up here. Alright, so we go ahead and put that into the calculator. And so this one, we go ahead and type it in, and since we have two significant numbers, 2 and 1, that 0 doesn't count because there's no decimal, or in the 4, 3, so there's 2. So tan of this is, so X is equal to, or our angle of depression is 26 degrees. Okay, so there's our answer for that. Alright, on page 526, number 41 and 43, those are the ones that you want to practice on, so you can pause it anytime. Okay, so here it's kind of nice, it actually gives you the picture. So we have our right triangle, and it gives us how tall this person is, right here, at 5.75 feet, and this angle of elevation, which is, that's what it says in the description, right? Which it is, because it's off horizontal there. And then is that, and we want to find the length of the shadow cast by the person. So the sun is up here, so the shadow cast would be this distance here. So here's our right triangle, and this is the distance that we're trying to find. So that's X that we're trying to find. Now here's our angle. So what is this in relationship to this side, the height of the person? Well, that is opposite. And what are we trying to find? Adjacent, right? Tangent. Most all of them are tangent. Oops. So tan of our angle, 23.4. Make sure that's in degrees. Right? Make sure when you do degrees that your calculator's in degrees. Right? If it's in radians, make sure it's in radians. And that is equal to opposite, which is 5.75, divided by our adjacent, which is X. So basically in this, right, we want to multiply both sides by X. On the previous ones that we did, X was, our variable was on top, right? So here we kind of just have to move it around, and some people already know, but basically this cancels out. And then I have to get the X by itself, so then I have to divide by tangent. So basically just the X is a variable on bottom, and my tangent, or my trig function of the angle, is just going to switch places, right? 23.4. So basically here's where we started, right? tan of 23.4 equals 5.75 over x, and we ended with x equals 5.75 over tan of 23.4, right? So basically they just kind of switch places. You could do it that way. You could also set up a proportion and cross multiply, that kind of thing. But here we go. So we're going to enter this into our calculator, and then we can get our answer of 13.3 feet. So that's how the length of the shadow. And so how we got that from the bigger triangle, so this is our right triangle. So this is also similar triangles, right? So if I have a triangle inside of that, this would also be 90 degrees, even though it doesn't say, but they're similar triangles, right? They have the same ratio of sides as such to the big one. The smaller one does to the big one, so that angle's the same. Okay, so number 43 is talking about installing a floodlight in a parking lot so it illuminates the employee exit. We want to find the angle of depression of the light to the nearest minute. So that means we have some kind of light, right? Some kind of light. Here would be horizontal. Say this is the building. There's the exit. And we want to find this angle right here, which would be the same as this angle down here. So I mean, really, you could use this as your right triangle. You could use this red one as your right triangle. So you're finding this angle, blue here, which is the same as this angle on the bottom left in blue, because really you just have, right, here's the lamp stand, which they say is 39.82, and they want to put this in nearest minute, so we're going to have to convert this in the end, times by the decimal 0.82 or whatever it is, point whatever, times that by 60, and that will turn it to the nearest minute. Okay, so if that's 39, isn't this right here, this distance of the building, even though the building keeps going up, this distance from right here down would also be 39.82. So either way, you're finding this angle in blue. And they're calling that angle from right here is the angle of depression. Okay. So it doesn't matter which triangle you solve for, this is the same distance. And this one, 51.74 feet away, is the same as this 51.74, right? So, all right. So we want this angle, which is this, these two are the same, right? They have the same measure. They're not the same angle, but they have the same measure. So what is the sides in relationship to this angle? Well, the 39.82 is opposite, and the 51 is adjacent, a tangent, right? So tangent of our angle that we want is equal to the opposite over the adjacent. And so that we're going to do tan inverse. So tan inverse of this ratio, 39.82 over 51.74. It's going to give us the angle, and then we're going to have to multiply the decimal that follows the decimal by 60 to put it in degrees and minutes and seconds. But they just want the nearest minute. So let's go ahead and do this on a calculator. Okay, so I got like, I'll show you. Just go here. So I got 37.58 and goes on forever. So what I'm going to do here, since this goes on forever, I'm just going to go ahead and there's a way that you can just do this. I'm just going to take away the 37 because that's in degrees, right? So that's my amount of degrees is 37. So I'll go ahead and put 37 degrees. And now I need to take this decimal, this 0.58, blah, 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 blah. So what I'll do is subtract 37 from this. And so that gives me just the decimal. And so instead of taking just 0.58 and then timesing that, because all this stuff is going to add up eventually, right? So I need to times that whole thing by it. So now I'm going to take that point, blah, 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 whatever, and times that by 60, and it'll give me 23. So you might have got something like 22.8 something, blah, 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 and then you'd round it so you get the same answer. But I guess this is just more accurate. So, well, I guess, yeah, whatever, 23 minutes. There you go. Alright, so there's your angle that you're finding. So that's how you use angle of elevation and angle of depression in word problems.